Going to build on the basics of data frames we learned last time. The link to that video is below in case you missed it. And today we're going to cover some exploratory data analysis on CSVs. So that will include reading and writing CSVs, dropping and renaming columns, using Boolean selection to filter rows in a data frame, and also some helpful methods for data exploration. First, we will go to our dataset for this episode, which is going to be this CSV, which is pretty small, from Kaggle datasets, which contains some information about all space missions from the 1950s. And the link to that is also below for convenience. We've imported pandas using the canonical import and printed the version for posterity. So this is the relative path to the location of the CSV which we've downloaded. And next we can just use read CSV and passing the path as an argument to create a data frame from a CSV. So let's look at the first two rows of that. And so here we can see the columns that are present in this CSV, and we can see the first two rows using this head method on the data frame, which we'll explore a bit more later. So immediately we can see that the first two columns seem to be index columns. So when we're reading this CSV, we can handle it at that time, say by using one of the columns as an index so that pandas doesn't make one. So we can do that like this, using the index underscore call keyword argument, passing the name of the column that we want to use as an index. And so in this case, we just have this one column that we might want to drop. But what I think we'll do in this case is we'll stick with our original CSV that has two extraneous columns, and then what we'll do is we'll remove both unnamed :0 and unnamed :0.1. So if we want to get the strings for the column headers, we can do that using the columns attribute that provides the names of each column. So here we can see, okay, these are the two that I'd like to get rid of. So now to drop those columns, we will use the drop method on the DataFrame object, and we can pass in a list of columns that we want to remove. So that's why we got these strings handy, so we could copy and paste them. And by default, this drop method will actually return another data frame without editing the original. So if we want to modify the original data frame, then we need to pass in place equals true. And this is a pretty common pattern with methods on the data frame object. So you'll need to be aware of which modifies in place and which you actually need to pass in place is true. Okay, so now if we look at the top two rows again, we now see that we don't have those two extraneous index columns. So great. Next, let's learn how to use some exploratory methods. And so we've seen the use of this head method, and what that is doing, as you probably figured out, is showing the top, in this case, two rows in the CSV. So it is worth being aware that a lot of data sets will have some sort of ordering to them. So in this case, there is an ordering in the data set. So we can use another method called the tail method, which will show the end of the data set, and we can see that these are all from the 1950s. The top of the file is 2020. So there's a temporal ordering to the data set, which is worth being aware of if you're using these head and tail methods to get a sense of what data is there. So for example, if we looked at just the top two rows, we might infer that, oh, this rocket field always has a float in it, when indeed it does not. A nice alternative to the head and tail methods is the sample method. So here I pass the integer 5 to the sample method, and this will provide me 5 random rows from the CSV. So this is maybe a nice default way of looking at a random subsample that might be more representative of the entire data set. And it is worth noting that by default, sample without an argument will return a single row, whereas tail and head by default will provide 5 rows. Another useful thing we might want to do when exploring our data is finding missing data. So we've already discovered that in the rocket column, there are some NaNs, which stands for not a number. And there's a pretty helpful method on the DataFrame called isNA, which means is there a none or is there an NaN, not a number, or nan. So we can compute isNaN and then compute the sum to see how many missing values there are on a per column basis. So let's see what we got. Okay, so it looks like, yeah, this rocket column has over 3,000 missing entries, whereas we don't have any missing entries in any of the other columns, so that's good. But that tells us a lot of useful information. And at this point, we might also think to ourselves, this is maybe not the most useful column name. Can we rename that to be more meaningful? And if we look at the page on Kaggle datasets, it turns out that what this column is the mission cost in USD. So that's why it's missing for some of these. Okay, so if we want to rename a column, then what we can do is we can use the rename method. And in that, we can pass a mapping of the old column name to the new column name. So I'll just copy paste the old column name and we'll call it something meaningful, like mission cost in USD. And again, we need to use the in place equals true keyword argument here as well. So now if I look at the top 5 rows, we should see, yep, mission cost in USD, and all the other columns are as we expect. So at this point, we might start to have some questions about the data that we can start to answer. So let's say maybe one of the questions is, which organizations have launched the most space missions? So let's write that question. Who are the orgs that have launched the most space missions? And it turns out there's a useful method in pandas called value counts that can provide us this answer. So it seems pretty clear that company name is going to be the name of the organization, and we can compute the value counts on that, value counts, and that'll break down how many rows are there with value equal to, say, SpaceX. Okay, so now we have this result, which tells us that this is the organization that has the most space missions and how many missions it has. So this is the sort of thing that you might want to put into a plot, which we'll discuss more next time. So in addition to value counts, which we could do on many of these fields, although it might not be as useful for, say, location or date, but it would be potentially useful for the status of the rocket or the status of the mission. So speaking of the status of the mission, maybe that's another good question. How do we select all of the failed missions? So this is a good time to introduce the Boolean selection. So let's write down our questions. Select all failed missions. So we'll use a Boolean selection to do this. So the way that this works is I can say to pandas, I'd like all of the rows where status mission is equal to failure. And that condition will return us a result that for every row will tell us whether this condition was true or false. So we see that there are some trues down here. And by the way, the type of this whole quantity, this is a pandas series. So we can use that series, the Boolean series, to then filter down our data frame. That means to select just the rows where the value of the series is true. And we can do that using the square bracket syntax, where we can just copy and paste this condition, drop it in between the square brackets, and that will provide us just the rows. So we can see there are almost 340 rows where the mission status was a failure. So that's another useful way to explore kind of different slices of the data. So at this point, we've looked at a couple of different questions, and we have spent some time kind of making this data frame a lot cleaner. It has better column names. We've removed some columns that were not useful. And so at this point, we might want to go ahead and save this data frame to a new CSV. And so we'll use this toCSV method to do that, which is a method on the data frame object. And so we just provide the path for this kind of cleaned up version, because there's no reason why, if we look at this again, we would start with a kind of a bit less clear version of the dataset. Okay, so now we've saved it as a CSV, and onwards we go. To summarize, in this episode, we learned how to read and write CSVs. We learned how to drop columns. We also learned how to rename columns. We used Boolean selection to filter the data frame down to specific rows we were interested in. And then we also used some helpful methods for data exploration, like head and tail, as well as those that help us look at missing data in the dataset, like isNA. From here, in the next episode, we'll pick up making some basic plots using the same data that we've now cleaned up a little bit. I hope this was useful, and thank you for watching.